So in this poster we have the inside of a wind turbine. We have the blades, which are these two that rotates. We have gearbox, which contain the gears and the high speed and the low speed. And we have three, the generator. We have this whole thing that holds everything together is called the nacelle. We have the weather station, and we have for sure the tower. So generating wind energy, first thing, the rotor. A computer turns the nacelle and the rotor. The rotor is the three blades and a hub. So that's the hub, and these are the blades. The rotor is the whole thing. So turns the rotor to face into the wind. The blades rotate when wind moves over them, which turns the rotor and low speed shaft. So it's programmed to face the wind whenever it goes. Second, the gearbox connects the low speed shaft to the high speed shaft to increase the rotational speed. Of course, when we have small and big gears, we have its purpose, to increase the rotational speed. 3, we have the generator. The generator uses this faster motion to turn magnets surrounded by copper wire loops. This creates electromagnetic induction, which then generates electricity. So it works with magnetic field and it rotates them to generate electricity. 4, we have the tower. The electricity travels down the inside of the tower through cables to a transformer at the base of the tower. We have a tower and we have a grid actually to collect the electricity to spread it all over the town or the city or whatever. We have 5, from the transformer, electricity flows underground to an on-site substation. 6, overhead power lines take the electricity to an off-site substation and into high voltage transmission lines. The electricity from the wind turbine moves through cables to an off-site substation. 7, here we have the electricity goes from the high voltage transmission lines into lower voltage distribution lines, from the higher voltage transmission to a lower voltage distribution lines. And 8, the distribution lines bring the electricity to customers' homes and businesses. So it's actually the mechanism, or like how we transform actually the kinetic energy from the wind to the mechanical energy and the turbine to electricity. So measuring wind energy, the amount of electricity generated by utility scale wind turbine depend on wind speed and blade length. So the higher the tower height, the more wind speed we get, by 25% faster. Wind speed at 164 feet compared to 33 feet would double the electricity output. Doubling blade length increase power output by 4 times. So when we double the length, we have an increase of the power output by 4 times. And that's it all about the wind turbines.